Welcome back to my channel Knowledge Chronicle.
Today we are diving into one of the strangest and most mysterious concepts in physics, quantum entanglement. Albert Einstein himself once called it spooky action at a distance. But what exactly is it? Why did Einstein hate it so much? And how does it completely challenge our understanding of reality? Let's find out. Imagine you have two particles, say two tiny photons or electrons, that are created together in such a way that their properties are linked forever. This connection is so deep that no matter how far apart they are, across the room, across the Earth, or even across galaxies, what happens to one particle immediately affects the other. For example, if one particle spins clockwise, the other will instantly spin counterclockwise. If one changes its state, the other reflects that change instantly. This is what scientists call quantum entanglement, a bond that exists beyond space and time. Einstein, one of the greatest physicists in history, simply didn't like this idea. According to his theory of relativity, nothing can travel faster than light. Information, energy, or signals, everything takes time to move through space. But entanglement seems to break this rule. If two particles are entangled and one changes instantly, how does the other know what to do? It feels like the universe is cheating, like there is some hidden secret communication faster than light. Einstein believed there must be some hidden variables that we just don't understand yet. That's why he called it spooky action at a distance. In the 1960s, physicist John Bell came up with a test, known as Bell's theorem, to see if entanglement was real or if hidden variables existed. Since then, multiple experiments, using photons, electrons, even atoms, proved that entanglement is real. In 2022, the Nobel Prize in Physics was awarded to scientists who conducted groundbreaking experiments on entangled particles, confirming that this bizarre phenomenon truly exists in nature. So yes, Einstein was wrong here. Let's simplify. Think of entangled particles as a pair of dice. Normally, if you roll two dice, each one lands on a random number independently. But imagine if these dice were entangled. Whenever you roll one, the other instantly shows the exact matching result, no matter how far apart they are. This is how entanglement works. The two particles are no longer independent. They behave as one system, even when separated by massive distances. This is where things get even stranger. Many people imagine that we can use entanglement like a cosmic phone, change one particle here, and instantly send a message across the universe. Unfortunately, it's not that simple. While entanglement is instant, it doesn't actually transfer usable information faster than light. The results appear random until they are compared later. So, sadly, we can't use entanglement to chat with aliens in another galaxy. At least, not yet. Even though we can't send text to Mars instantly, entanglement has some powerful real-world uses. First, quantum computers. These use entanglement to perform calculations that normal computers could never handle, potentially solving problems in seconds that would take classical computers millions of years. Second, quantum cryptography. With entanglement, scientists are building communication systems that are completely unhackable. If anyone tries to intercept the signal, the entanglement breaks, and the system knows instantly. And then quantum teleportation. Yes, teleportation. Not like Star Trek where people vanish and reappear, but scientists have successfully teleported quantum states of particles using entanglement. This could really revolutionize data transfer in the future. Entanglement also raises deep questions. Does the universe exist in a definite state before we measure it? In quantum mechanics, particles don't have fixed properties until we observe them. This means reality itself may be influenced by observation, and entanglement makes this puzzle even stranger. It's almost as if the universe is not a collection of separate parts, but a deeply interconnected web where everything is linked. Quantum entanglement is one of the most mysterious discoveries in science. It challenged Einstein, it broke the laws we thought were unbreakable, and it's shaping the technology of the future. Whether we call it spooky action at a distance or the secret language of the universe, one thing is clear. Quantum entanglement shows us that reality is far stranger than our imagination. If this video blew your mind, then don't forget, Your one like, share and subscribe will help us create more valuable content.